Okay, so training jobs. So you may remember yesterday we were talking about gradient descents, right? And talking about ways of calculating, how do we optimize for minimizing the difference between the data reality and the predicted reality, right? Which our model is generating the predicted reality. So we talked about like the different kind of ways in which we can approach getting like to the global minima and avoiding like the traps of the local minima as far as it comes to the differences, the loss function between what we know is true from a data perspective and what we're trying to predict towards. Just to mention this, we also talked about overshooting and the global and local minimas, and how the learning rate is the size of the changes that we're going to make as we kind of explore to get to this particular curve right here. So one thing that's inside of SageMaker is how to run, it's just training jobs. So literally with either the SDK, either Bodo or with the SageMaker SDK, you can literally just call and set a data source like an S3 bucket, and then just have it like invoke training jobs of whatever specification you want to. I'll just set that up later, actually. So here are some options, by the way, which I've kind of referred to, but typically you can actually use SageMaker's built-in algorithms, of which there's 17 at last count. And this is you just putting data through basically pre-created Docker containers that contain all the code and the model and all that other stuff. Now, you can also create your own custom scripts that you can run against the containers. So this could be R code, Python, Julia, and you can run against supported frameworks like PyTorch, Chainer, MXNet, that kind of thing. And then all the orchestration, all that's handled again still by Amazon. And all you're doing really is you're either modifying the algorithm or you're modifying your code. Now, if you want to change the framework, that's going to require you to generate your own Docker container. Now, this is going to show up on the exam in that, it's going to have a question like, hey, you want to run your own custom algorithm using your own custom MXNet modified framework or whatever. And they're going to give you a bunch of answers, and it's going to be pick 2 out of 5 as an example. And 2 of the 5 are going to be about you bringing your own container because you're modifying the framework. If all you want to do is modify a little bit of code and you're not changing the algorithm per se, you're not trying to edit the built-in algorithm, you're just bringing your own algorithm. So let me clarify that. You cannot edit the built-in algorithms inside of SageMaker. You can bring your own algorithm, which is the blue option, or you can bring your own algorithm and you can bring your own custom framework. And that you have to generate your own Docker container, and that container image needs to be pushed to a repository that SageMaker can pull from. Typically, that's going to be what's called ECR, the Elastic Container Registry, but it could be another hosted function inside of Amazon. But just be aware that when you start modifying the framework, you want to do major own custom frameworks, you have to bring your own Docker container. Otherwise, it's just code, right? It's just you changing code at that point. I feel like I'm missing chat. Hold on. Where is it? There it is. So Rachel, MXNet, TensorFlow, scikit-learn, PyTorch, like the chainer, the things listed at the bottom of the blue one, right? If you want to use your own custom framework, or you want to like heavily modify, change, dissect, or shift any of the existing ones, that's when you're going to bring your own Docker container. I hope that's clear. Yeah, so if you want to use something other than MXNet, TensorFlow, scikit-learn, PyTorch, or Chainer, then, right, those are supported. If you want to use something else outside of that, just as an easy segue, then you're going to have to bring your own Docker container for that.
Can you use Bodo 3 for all of these options as well?
Well, let me be clear. Bodo 3 is not really an ML framework. It's an AWS SDK framework, right?
Mm-hmm.
So you can you can manipulate all of this with Bodo 3 or the SageMaker API. The only thing that would change if you're doing the purple one with your own custom script and custom framework is if you were like, you'd have to have that loaded as a container into the container registry. And so you just have to have a pointer in your code to where the custom container is. That's it. So you could use Bodo in the SageMaker SDKs to call that custom container. So all of this can still be orchestrated using Bodo 3 or the SageMaker SDKs. The only distinction is that you are going to be pointing to a custom Docker container if you decide to do the purple or the last one, actually, which is third party.
Yeah, sorry. So I meant for all of these, you can use Bodo 3. I understand for the custom framework, you need to point to a container. Are you saying that there's a difference in where you need to point for the custom framework between Bodo 3 and the SageMaker SDK?
No. Well, they do operate differently. So let me be clear. The functions, the modules inside of them operate differently in terms of how they're structured. But you just have to you need to, for the option parameter for that particular call, you actually just need to specify where the container registry is and what the container is. That's it. So they both function like logically the same way, but syntactically they're slightly different.
Okay, but for both, you would need to, for the custom script, you would need to register your container with ECR.
Yeah, you only need to do you only need to do your own Docker container if you're messing with the framework. If all you want to do is change the algo, like upload some code and change that, then that's just code that you're going to upload as part of it being submitted out to as a job inside of SageMaker. That's all.
Yeah, I understand why you're doing when you're doing the custom. I'm just trying to differentiate between Bodo 3 and the SageMaker, because all these notes only mention the SageMaker SDK.
Yeah, so Bodo 3 is for all of AWS manipulation. So it's an SDK to manipulate all of AWS's infrastructure. And it just so happens that it does include the SageMaker, like an API calls. The SageMaker Python SDK is specific just to SageMaker. And so when you pull that in, that has a little bit of a higher level abstraction than Bodo 3 does against SageMaker. So they're different SDKs. The top one, the SageMaker Python SDK, is just focused on SageMaker. Bodo 3 is for all of AWS. So you can make EC2 instances, create buckets, do all kinds of things that you can't do with the SageMaker SDK.
Okay, and then for options for scripts, algorithms, and models, you can use both of them. And on the in the weeds, they operate differently, but
yep.
Is there any process change between the two of them?
You'll see it actually. So you'll see it in one of your examples. Okay. Yeah, but for the most part, I think they leverage the SageMaker, but they do weave in Bodo, so you'll see that woven in as well. But again, logically, how they function is identical. It's just syntactically how it's specifically different. But I mean, they pass the same parameters because it's the same API on the back end, just so we're clear, right? It's the same API on the back end.
Okay.
Let's see, Nicholas, as far as like a custom script, like if you wanted to change your algorithm, for example, let's say you didn't want to use built-in, you could actually like submit and say, hey, I want to use scikit-learns, blah, 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 blah. You could specify a different algorithm and go off the default. So the green one and the blue ones, you don't need your own container. The purple one and the pink one, the last two, you're either going to create your own container or you're going to source it from a third party. Yeah, changing code, that's easy, right? You just submit the code, right, as part of your like training job creation process, and it will just execute it. And again, it needs to be obviously Python or Julia. That's it, easy. No need to change the container, just submit it when you call the job, either using the SageMaker SDK or using Bodo 3. It's the last two where it's like, oh no, you want to modify the framework, then yeah, we're gonna have you just pull down an entire other environment. Because if you think of Docker containers as really portable environments, when you start changing like the framework of the environment, then they want you to go container on that at that point in time. If you're just changing the code, they're like, yeah, we'll just deal with it as long as it's valid code and gives us the, receives the right inputs and gives us the right outputs. We don't care, right? No, Thomas. In order for the third parties to work, they actually have to be containerized. So, to be clear, you're generating the purple one. The pink ones, when you go to the third party, those containers are typically already pre-built. They're going to give you the container like registry plus the name of the container, and you're just going to pass that into your job, right? And assuming that you have actual access to it, right? Because they enable that on a per account basis. Then you can then pull that container from that third party, and it will contain the algorithms, models, and whatever that you need. Yeah. So one thing worth noting is that when we were looking at SageMaker before, marketplace. So for example, you could grab a different kind of model packages, right, that are already pre-built, right? You could grab specific algorithms if you wanted to. Notice there's not a whole lot out here, especially compared to the marketplace. If you're looking for data sources, right? Again, not as massive as the general marketplace, right? But it's here. I don't think that the here, at least, this is really taken off, because I just want to point out that most companies now are probably selling this as a product, right? Or offering it via APIs as a product. So, but there are some out here. Okay, so let's not leave this, right? Make sure that we're clear about this. Green and blue, first two, do not need your own container. Purple, you're going to make the container. Pink, the container is going to be provided for you. Either way, with purple and pink, the last two, you're going to have to specify the location of the container when you submit the job in question. Okay. Purple and pink, the container is going to be hosted in the Elastic Container Registry or some other location that can be pulled from by SageMaker, right? And so the first two, the green and the blue ones, since they don't require you to bring your own container, all you need to do is either just call the job for the green one or call the job with your kind of like code importation, if you will. That's it. Supported frameworks are listed down at the bottom of the blue one. Anyone have any questions about this?
You just said it, but I missed it. Where will we point to for the container?
Oh, the Elastic Container Registry, typically. Yeah. Daniel, just to say this, most people do blue and green. I rarely meet people who write their own like framework, who do their own Docker container. And then when I do, and I ask them why they did it, they did it for what I would easily consider non-valid reasons. They could have just done that as a script. They could have just modified the existing framework or the outputs of the framework instead of, yeah, they're like, when I asked them what their justification was, it's like, well, we didn't like the way it looked, or I don't, I don't want to use any of the standard frameworks. And it's like, okay. But there's no good reason. It's like, I just don't like them. So I honestly, purple, green and blue is what I see the most. I don't think I've ever worked with anybody who's worked with pink. And purples usually end up with weird justifications. Yeah. In other words, if you're going to go that far, typically those will be environments that actually already have their own ML environment, like they're using Kubernetes to host their, internally, right? Or on AWS to host their own ML workflow, and they're not using SageMaker. So. Okay. Other questions? Just want to make sure before we move on. Now, I find this interesting. Is it just me, or does that say 250 ml model packages and algorithms? I just want to say this, is that really? Because I get a sense there were 250. Maybe I'm just not scrolling through all the pages. 1, 2, 3, 4, 5, 6, 7, 8. Let's see. 1, 2, 3, 4, 5, 6, 7. Am I missing something? Are these just the featured products, or are there more? There's more. So I don't know why they do this, but they do limit everything when you come in here. So make sure you click on see all products, because they do make it so that you can only see what they featured. There's a lot more in here. Hey, there's the Bitcoin daily average price. Again, I would say that oddly enough, even at the levels we're talking about, this still is not as heavily populated as the overall kind of like marketplace. So just something to be mindful of. Oh, that's right. I meant to tell you this also. Be careful, because sometimes you will have to pay like a daily, hourly, usage-based licensing fee in addition to like a general charge of like, hey, here's $500, we'll give you access to the data set, plus $2 an hour for every training, training hour. Be careful. Make sure you look at any subscription fees, because here's the funky thing. It's going to show up on your Amazon bill. They're not going to charge you separately. So since most of us don't see the Amazon bills, right, it's going to be hidden from you, and you're going to agree to something. So yeah, so just make sure you read the details to find out like what the surcharges are going to be. Okay. Yeah, so as noted here, it is consolidated into your AWS bill. All of this, by the way, is usually accessed through some form of API or the container, a container registry, like a container itself. Okay. All right, so let's talk about parameters and hyperparameters. Were there any questions about this page before we move on? Okay. So parameters, I think we've already talked about, right? These are the things that, the weights and the biases, for example, that are updated when we're training our model, right? So these are tuned automatically. These are done by the algorithm model by, training, right? All hyperparameters are set before training the model and can be tuned by the user after the model. And these include things like, what is the actual learning rate? How are we going to, what size of change are we going to make every time we run either through a data point or through a data set, right? What's the batch size, right, for how we're going to learn? What are the number of hidden units, for example? Do we want to pre-initialize the weights? Do we want to randomize them? Especially if we're doing neural networks, like what does that look like if we want to do a learned training and bring that over? So there's going to be more on hyperparameter tuning later on. So that was just a primer. Just like we're going to talk about this when we get to model. I'm sorry, when we get to hypertuning, which is one of the last modules we'll do tomorrow, and you'll actually have a lab on hypertuning. One thing I want you to pay attention to, both with this lab today and the lab tomorrow, is that you actually will be doing deployments, which means you're going to be deploying a virtual machine behind an API like a SageMaker endpoint to which you can submit data and get predictions back. Now, the reason I mention that to you specifically is that, if you had to do this manually, you'd have to set up the instances, put up some kind of API gateway or some kind of autoscaler or something to intercept that API call, and then be able to scale that out to multiple machines that all had the trained model on it. In other words, there would be all this application deployment you would have to do. SageMaker takes care of all that for you. The problem is that when we're running these labs, you're doing production grade deployments, and it's just like 10 lines of code, and you have no idea. So when you're running the deploy function, right, when you see the word deploy after your instantiated object, look for that, because, and the reason that could take a second is because you're actually standing up one or more virtual machines that are acting as like productionizers behind your production endpoint. So these are your production environments. So I just want to mention that because we are going to talk about hyperparameters, but the other thing is that deployment is also kind of baked into labs 3 and 4 in particular. So make sure you're paying attention. Okay. Because it like trivializes it. And I gotta tell you, like I mainly deal with this a lot in Kubernetes because especially a lot of established enterprises haven't rolled over into like SageMaker or any other third-party kind of ML hosting. And it's a lot harder in those environments than it is here. And so I just want you to note that like the benefit of that is that you are actually deploying what could be a production ready model. All that needs to happen is to just turn the dial on the scale. That's it. Okay, but we're going to talk about this tomorrow. So hypertuning is going to come later. Now here's a little visual about containers and data and how this relates back to your training code and your training data, right? Which goes into the model training on your ML instance, right? So this is where ECR comes in. The ECR stands for Elastic Container Registry. And anytime you run either like a Docker build command or a Podman build command or any of the other container build commands, you are generating a bootable container image that needs to be stored somewhere so that machines can pull that image down and run the code. So to kind of draw this out just a little bit, what happens is that in an alternative environment, let's say it's your development environment, or as part of a CI/CD process or build, like any kind of build process, what will happen is that your code is probably going to land in a repository and that's going to hit some kind of CI/CD process. This is going to generate a Docker image, which will then be generated, let's say here, and then it'll get copied up to the Elastic Container Registry. And let's say in this case, this is our training image. What will happen is that this whole purple box that's here is actually going to go and grab the container image in order to pull this down. So it's going to pull the image back over here. And so what's going to happen is you're going to end up with that like container image, and it's going to be over here running on the virtual machine that you specify when you basically run deploy. So in this case, I think it's still an ML M4 X large. So Docker containers are meant to be, it's application virtualization. So as long as the processor and the operating system match, you're going to pull this container to any Linux box that can support containerization. So it doesn't matter whether it's Ubuntu, RHEL, blah, 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 nobody cares, right? In this case, it's going to be Amazon Linux, but it's just going to pull those containers to all the boxes. So for example, if your endpoint for model training has 4 boxes behind it, all 4 of those boxes are going to go back to ECR, the Elastic Container Registry, and they're going to pull a copy of this model down. Now, if you're training, that's actually not, unless it's a distributed algo, you're not going to do that. But for running this in production, you could easily have 4, 10, 100 boxes who all have the same trained model, which is in your yellow container. And what they do is they get data and they make predictions. So you could literally, you could have 1,000 boxes if you wanted to behind that endpoint so that they could scale and be able to answer predictions, you know, in a timely manner. So to visualize this just a little bit, you will have, you know, typically in production, you're going to have what's called a production endpoint. And that production endpoint is going to point towards multiple boxes if necessary. How many boxes? You know, that depends on your latency. You know, how long does it take for your model to return a prediction, right? That kind of thing. How many concurrent recommendations per second are you going to support? Now, most of that is ML ops stuff, which hopefully you have somebody to help you with, and you can just focus on writing good models and dealing with that whole thing. But if you don't, just know this is how it works. They're not going to go past this as far as like deployment. You're not going to go much deeper than this, but you do need to know that behind a deployed endpoint, you can put multiple virtual machines that has your trained model ready to go. Okay. So in this case, assuming that my little red arrow is me making a production call from an app because I want to get a recommendation, you're going to hit the endpoint, and the endpoint is going to route to whatever box is available to return it. The box is going to return a prediction, and then it's going to go back to the application that's making the call. No, Joel, I'm not talking about training. I'm talking about deployment, like hosting a product, like the inference. I'm talking about running a trained model at this point in time. For training purposes, you don't necessarily need an endpoint. You know, if your algo supports distributed training, then you can do that. But just know that that's something that requires a little bit more setup and is a little bit beyond the scope of this class, right? Because then you're gonna have to take, right? And don't be wrong, if you want to run multiple model runs at the same time, you can just execute those, but you're not going to have a single endpoint with multiple virtual machines behind it, except if you're running in production typically. Yeah, so this is a production setup. Now, obviously, SageMaker can only really pull from S3. But there were two other technologies that you could throw in that could also pull from S3, so you could have a faster, in a sense, cache. Does anyone remember those two technologies? Those two like file system technologies that you could put in between S3, for example, that you could put like at this level? Yeah, good. EFS and FSX for Lustre. Okay, which of those was the fastest? Yeah, Lustre by far is the fastest. It's actually designed for high performance computing. So Lustre is faster, but it's also more expensive. So just gonna keep that in mind. Okay, so you got your training image. I probably should switch to an arrow there. You got your training image, you got your source data. Both of those get pulled back, right, into your model for training. So now we've switched off the deployment. I'm back to training, right? So you're pulling this in for training. So when you call your, like, you're fitting it, you're basically executing training at that point in time, which, by the way, again, you could run multiples in parallel. The only catch is that make sure that you're methodical about, did you like shuffle the data? Did you change some parameter? Is this part of a, an iterative k-fold with shuffling kind of setup? Just make sure that, there's ways of orchestrating multiple jobs running in parallel that all use the same training data and perhaps all use the same training code. Okay. Now, whether you use the built-in algorithms or you customize the existing framework, neither of which requires you to provide a Docker container. So going back to our original diagram here. Sorry. Worcester has no control over his fingers today. Hence why his lock was broken, and just decided to go back home. Anyway, this is why we were here, by the way. Remember that you don't have to provide any containers for blue and for green. You have to provide a container for purple, and you have to, you are provided a container from a third party, or at least an API call from the for the third party like marketplace. Okay. So the reason this is important is that even though you're not creating a container for blue and for green, a container is provided for you. And by the way, you can typically find those containers actually out on like GitHub. You can actually find like their like, extreme gradient, their XGBoost like container out there. So Amazon does share how they build their containers. So you can then pull the container back and modify it in case you wanted to do your own purple. Right? You could actually source it from the same containers they're using here, and you could actually like pull it down, modify the container, and then make it your own custom framework / script or whatever, right? So just know that you can actually also pull those containers down also. Joel, good question. So just to be clear about EFS's role, it sits in between. So earlier when I drew the little red box in between here, that was to show that it sits in between. So it acts as a cache. Now, what does that mean? Is that you could, what that means is that when you are like in file mode, for example, you're pulling the data down to EFS. When you're in file mode, you're pulling the data down to Lustre, which means that your subsequent access to that training data is actually going to come off of EFS or come off of Lustre, and it's going to be super fast, right? So Yeah. Now, if you're in pipe mode, by the way, you're not copying any files. So in pipe mode, just to say this, in pipe mode, you're pulling straight from S3. So all you're doing there is you're basically pulling in enough data at a time in parallel simultaneously so that you can have enough of a data set to get started, and then you're just going to stream it out. But the only thing you're doing here is that you're writing temporary files down onto EFS, right? Okay. That's all you're doing. Is EFS faster than piping? That I would have to test, right? And here's why, Nicolos, is that in general, EFS by a default, I don't think is going to be faster than piping, especially if it's in protobuf. But here's the catch. If you turn the dial on EFS's speed, because you can actually make EFS really fast, it's going to outperform. EFS and Lustre are going to outperform anything from S3 if you turn the dial on their speeds. Now, the more you turn the dial on their speeds, the more you're going to pay, right? But in general, like default EFS, I don't think is faster than pipe mode with protobuf inside of Amazon S3. But if you like even just turn it up just a little bit, it's going to be faster. And Lustre is just by default faster than S3. No modification necessary. It's just going to be fast. So, because think about like S3 is a remote storage system. So in pipe mode, since you're running things in parallel, you do get actually a speed increase. You get like 5,500 IO per second or something against the file, a single file. But like EFS, I mean, you can get 100,000 IO per second against a file if you turn the dial. So in general, once a file is cached on EFS and Lustre, you know, that's going to be slightly faster. But as far as like direct raw copies, right? Pipe mode on with protobuf with S3 is really performant, but it's easy to make EFS and Lustre way faster. So in general, in terms of speed, think Lustre, EFS, and S3. I know I just said that about protobuf and S3, but like Amazon doesn't see it that way. So when you take the test in ranking of fastest to slowest, it's always Lustre, EFS, and then S3. Okay. But in actuality, S3 in pipe mode with protobuf is actually faster than default EFS. Oh, let's take a look at this really quick. Derek, thank you for posting. All right, so this is just the raw SageMaker SDK. There are, let's see. Oh, you know what?
If you scroll down into that, Michael, it goes into the various algos, I think. Or yeah, right in here. Like XGBoost number 8.
Yeah. Oh, and so in here, basically, you'll find the links to the containers.
Yeah, I think so. I didn't do a whole lot of studying. I stumbled on this yesterday.
Yep, there's the original. I didn't know that they were embedded in here. Usually I just go and find them. Yeah, but yeah, somewhere, you know, again, I don't have a compiled list of links. I usually just end up searching for them, but all of the Docker containers they use for the built-in algorithms, I haven't looked for everyone like ResNet or, you know, FSN, but I think they're all out here actually. So. Good. Okay, so I hope that explains how that process works behind the scenes, is that you're using Docker no matter what. The difference is that if you're just using the built-in algorithms or just changing some code, they're going to provide the Docker container. If you modify the framework, you have to create your own custom Docker container. And if you use the third party, typically it's either a code change, but a lot of times they're just going to give you a Docker container to use. Now here, by the way, they imported Boto 3, which basically gives you broad access to all of the APIs in AWS. And then they imported the SageMaker SDK, right, which is specific to SageMaker. Now they're setting up a SageMaker session object. And then here, It's funny how they just name it PCA. That's fine. They are basically calling an estimator class. So just know that's really common. And note that, by the way, that you're not having to define any of the like the container parameters because they're using built-in for this. Notice that it's one instance count, so we're not doing distributed training, and they're using the M1C4X large for that. And then the output location is really not defined, and then the SageMaker session is just referring to the previous instantiation, right? There's some hyperparameters set there, which we're going to talk about when we get to hyperparameters. We're not going to peel back, by the way, every single hyperparameter that you could look at, because that would be just us looking at the documentation for days on end. But like if you're doing mini batch to gradient descent, for example, there's the mini batch size, you know, the different modes or objectives of the various algorithms can be defined. And then notice that, you know, they've kind of like set everything up in the estimator. They've set some hyperparameters, right? And of course, they're actually executing the training call by calling PCA fit. Yeah, absolutely, actually. So Peter raised a valid point, is that performance profiles will shift on whether or not you're doing distributed computing or not. But just to be clear, everything changes when you do distributed computing. Right, Peter? I mean, everything shifts for the most part, right? How you approach it, how you divvy up the data, right? Everything changes about how you approach this versus a single instance run versus a distributed run. Because what's the famous quote from that everyone always touts? Distributed computing is hard. Right? So yeah. And not necessarily relevant for the exam, but certainly relevant for just general understanding and mindset. You know, all we're doing is single instance runs here. We're not doing any kind of distributed training or and it's not the same thing. Distributed training, the concept of taking your, you know, data set and distributing across a bunch of computers, having them compile results and then having them aggregated back, that is not the same concept as just having a single entry point in production for inferences across n number of boxes, like whether it's 10 boxes or 100 boxes. That's just, those models are already trained. And so that's not, you don't have to worry about distribution at that point in time. All you're doing is putting more engines, more horsepower, if you will, into how your endpoint responds. When you're doing training, you have to worry about distributed computing and all of its facets, right? Including data distribution, aggregation, you know, retries, error corrections, you know, all these other like facets for it. So Peter, I didn't know if you had anything else to add there, if you had run into like a specific challenge. Or you just wanted to make sure that we noted that everything changes with distributed computing. All right, Rachel, that's a good question. Anyone, where is this all going to run at?
Container,
Sorry, Nicolo, say that again.
in a container,
Well, it's definitely going to run a container, right? But where, I mean, like,
and a SageMaker instance.
right. So it's going to call basically a training job of a certain size, Rachel. So what's going to happen is that, you know how when we went and ran notebook instances, we went in and created an instance and we specified a size, and that's where we're running our Jupyter notebooks. This is going to do the same thing, except it's all going to be behind the scenes on the section of SageMaker called training jobs. So assuming that I can remember how to compute, let's go take a look at this. So for example, under training jobs, right? I only want to know what I was doing. Anyway, moving on. So these are all training jobs, right? So these are instantiations of me running a training job, right? And so inside here, right, what happened is I called it. And by the way, you're only going to get charged for when, as long as the training job runs. So I got charged for 72 seconds, right? Now, notice that I actually did an ML large. The rest of this, by the way, was all just like defaults. I didn't change really any of this. My input mode was file, by the way. Notice it's not pipe. My data source was S3. I had, you know, a channel for training data, a channel for validation. Here was where it was located. Right? So I know, Rachel, I know this is like a point of abstraction, but what it is that when you call this code, it interacts with AWS's SageMaker endpoints, launches a virtual machine on the back end, puts all of your code, you know, and data inputs into the model, executes it right in a Docker container inside the virtual machine, and then like trains everything out and then outputs it to an S3 bucket, like the trained model and anything else that's relevant. Right? Kind of like looking at this training job going, what was I doing? I think I was messing around with hyperparameters actually. Anyway, yeah, absolutely. Yeah, no, it spins up a new one for training, right? Yeah. Well, because like your Jupyter notebook just needs to be big enough for you to mess around with, right? So you can do visualizations and look at your data set and do blah, 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 you know, right? This is where you're going to execute that. You're going to train the model. You might want a bigger box. Now we're not doing that here, but like we could run bigger boxes. And in the quick labs, by the way, they're not going to let you do that. So please do not deviate from the lab instructions, right? But I was sticking with this because I think I was like modeling out the existing lab environment, but honestly, M5s or even M6s would be better for this. As far as speed goes. By the way, so look for this today. Look for the like where it defines the session where it's going to call an estimator. Look for this. Look where it's gonna, and I don't know. Today, definitely tomorrow, not today. I don't think it's going to set hyperparameters. It might. And then look where it calls fit, right? Where it's basically going to like train the data. So look for that today. Hey, I guess we're supposed to create a SageMaker training job. Okay, sorry. I think my brain was a little out of it just because I came late to the whole thing. All right, so if we go and create a training job, let's say, and I'm actually not going to run this since I already have running jobs that I can refer to, right? But here, by the way, is where you're going to say, hey, I'm going to use the built-in algorithms. I'm going to use my own algorithm resource. Notice that that's going to change, right? By the way, you have to have this defined inside of SageMaker, right? Code-wise in order to invoke this. You might say, well, where was that at, Michael? Well, hold on. Let me show you. See where it says algorithms, right? You have to create your own algorithm, right? And you're gonna have to create your channels, your specifications, your metrics for success. Are you gonna accept compressed data types? Like just know, right? You can actually define all of that right here. Now, let's say, and then you can bring your own container. Notice it says NECR. So you're gonna have to put the path. Notice it gives you an example path for container registry. And then an algorithm subscription from the marketplace. If you've subscribed, it'll actually show up as a resource that you can like search and bring in. But let's say we just stick with SageMaker's built-in algorithm, right? So I think before I was doing XGBoost, right? By the way, here's the registry path where so it's going to show you where the container is stored. Sorry, I was just reading this because for some reason I haven't seen this before. Notice, by the way, it's like hard-coded to file. So notice there are limitations like based on the particular algorithms. Think about this for a second. So let's say I was doing linear learner, I could switch to pipe mode, right? Notice it's not like necessarily specifying or requiring me to use a like particular file format for that as long as it fits. Let's go back to XGBoost. Let's stick with file for a second. All right, so it, by the way, will by default will publish metrics out to CloudWatch that you can then track. You could use CloudWatch events. Notice I said CloudWatch events. CloudWatch events to trigger like data jobs or other things to run. You could also set an alarm, a CloudWatch alarm. Notice I said alarm, not events, that says, hey, if the training error gets to a certain threshold, then, I want you to run an alarm, right? You can do that kind of thing as well. That, by the way, will be on the exam. So alarms are used to trigger alerts. Events are used to trigger like responses. Like if you want to trigger a training job, or you want one model when it's done to trigger another model, like that kind of thing. Now, notice the instance type listed here. This is my own account, so I actually could go through and use other more modern instances. I'm so shocked this is even here. By the way, I can't even find pricing models. Like the estimators don't even do M4 X large anymore. Notice if I want additional storage, right? I can do that. I can do encryption here as well. I can set maximum runtime. I can specify it into a VPC. Notice there's an ML pipeline VPC that I could spin it into. Then I could choose the subnets. And then you will have to choose firewalls for it if you do this kind of thing. But frankly, typically I don't run it in the VPC. You can go through and modify the hyperparameters if you want to. So like if I wanted to, change the num classes, or right, I think you can even add additional ones. So used to doing this in code. Now, you can create up to 20 channels of input sources. I just want to say this, right? You're going to have to know what the input channels are. And they have to be spelled exactly as they are in the documentation. So one time, just messing around just to show how sensitive it was, I put validation in here with a capital V, and it was like, nope, job's going to fail. So these are just input channels, which basically says like, what am I going to bring in, right? This is also where you can specify pipe and full. You can define the content type, right? Compression, if there's any kind of like record wrappers around it. What's the source? So you can actually source from a file system. If you already have your training data sourced, already copied into EFS or already copied into Lustre, you could do that as well. Typically it's done as a pass-through where it's like the instance is loaded and it sources it in. But just know that you are going to have to pull it out of S3 and put it into EFS or pull it into Lustre. But typically that's not where it stays long-term, right? Just depends on what your policies are. And then you can add additional channels like, this is a validation, for example, would be a valid one here. And then if you wanted to periodically generate checkpoints, right? Used to resume spot training jobs. So for example, spot training, spot is a type of EC2 instance that's up to 90% discounted. So if you're running training jobs consistently, but you don't have a really strong time delineation, you can actually like run it on spot instances. Multiple channels, by the way, are sources of data. Like where do you get your validation data? Where do you get your training data? Where do you get your testing data? Right, Mackenzie, that's what it's for. It's like, where do if I split my data set, where do I get the different types of data? Where am I going to source those? Right, because for example, your test data shouldn't have any labels in it, right? So that's going to be a different data set than your training data. And obviously it should be distinctly different just as in and of itself, right? But as it goes through different phases, it will execute different validation, different channel inputs. And then where you output your data, as far as like where it's going to like dump the model or any other outputs. If you wanted to enable spot training, you can do that. There's a lot here. Now, what of this is actually going to be on the exam? Valid channels, like these channels for input sources, that concept is going to be on the exam. And the fact that you can actually modify some of these hyperparameters, but not specific hyperparameters, like other than like learning rate as an example, are going to be here. The fact that you can stick it into a VPC that you could actually is going to be on the exam. I don't think stop conditions are on there actually. Not that I saw. And that's it. And the fact that metrics are automatically generated for you for built-in algorithms, and they're going to be stuck on CloudWatch. And then of course, the fact that you are sourcing a container and that, you're going to source your own, you're going to specify your own container, ECR container registry if you're modifying the framework. So that's really what's going to be on the exam. Well, let's go look at a training job that ran. Actually, where's my failures at? Probably could filter off failures. Wow, I ran a lot of those. What was I doing? Again, just to kind of look at this now that you kind of makes a little bit more sense. Notice that it's giving me the total training time. Here, by the way, is just the history of it running. It was only 4 minutes. Didn't specify the algorithm. That's interesting. Almost positive this was XGBoost. I wonder why it's not saying that. Notice that again, extra large, M4 extra large. I used a 30 gig volume. I did have a maximum runtime, so there was a limit to how long I let it run for. There was a train channel like here for input data. Notice that it was S3. It was the CSV. There was no compression. Here was the source. Here was the validation data. Again, CSV, no compression, right? S3. Here was the source. Yeah, this was definitely XGBoost. I wonder why it's not declaring the variable. And then here are all the like the metrics that it threw into CloudWatch. Here was the output, so I could actually go and look at the train model. Like you can pull it down. I think it's in Pickle by default. Anyone ever peeled apart a model, like of the file of a model? I think it's in Pickle. It's in Apache Pickle. Which some of you are like, what? Others of you are like, yeah, it's weird. I didn't put this in a VPC. Oh, this is on the exam. This is definitely on the exam. I was shocked because it was in the practice exams and it was on the exam. Is that if you need to isolate your machine learning because you're dealing with sensitive data, there's a checkbox in the networking where you can say, look, I only want to have inter container traffic encryption, right? So in other words, if it's talking to other containers, everything's encrypted. So just know if you have sensitive data and you want to keep it super private, this is one of the options. It's not, why does it keep doing that? Then you got monitoring and debugging underneath your actual job, and you can add this all to a dashboard. Let's just look at the last week. God, you must have not eaten hardly any horsepower at all. Look at that. 0.98. Yes, we'll see. I'd like to see how that actually really performs. Here's the model artifact. If I want the S3 models, there's the TAR-GZ. I believe actually you do have to use a VPC when you're doing intra-container. Actually, that's not true. If you're doing intra-container traffic, you don't actually need to use a VPC. But if you're on a VPC and you want it secure, you actually need to click container traffic. Bottom line is that you're doing encryption for data in transit. But if you do put it on a VPC, just also make sure that the VPC is private, right? Thomas, channels are data inputs. So training, validation, test data, those are all inputs. Those are all like the channels are data sources, basically. They're data inputs. I don't know why that keeps popping up. Yeah. Can I even get to that? Yes, I can. How tiny that little model is. Of course, it wasn't a huge job, right? I've seen them get a lot bigger than that. And I say that like I've seen them a lot bigger than that just because natively the formula was a lot bigger. Changing like number parameters and weights and biases inside is not, these are not going to get super huge. So it's not like the more data you run through them, the bigger they get, right? That's not really how that works. All right. Cool. Questions about that training job, which is mysteriously keeps popping up at status history. I'm curious about one thing. Let me go back to training jobs for just a second. All right, let's say I gave it, just bear with me 1 second. Just want to see something. Built-in algorithms. Okay. Yep. Gotcha. Let's say we're going to stick with this. No custom encryption. Just stick with the standard count. All right. Here it is. This is network isolation. So this basically enables it so that the network is completely isolated, right? And so whether it's in a VPC or not, shouldn't make a difference. Right?
I feel like I've seen on a couple of practice exams that like the best answer is both. If you're on a company private VPC.
Yep. That's what I was just saying. I think that's consistent. Yeah. In other words, honestly, if you're not in a VPC, you're already in Amazon's private network. So, if you don't have to be in a VPC, that's actually the most secure. Because if you're on SageMaker's like internal network, there's no chance of anybody seeing you or even getting to you. If you put yourself on a VPC, you obviously want a private VPC, which means it doesn't have connectivity to the internet, but just know that someone could change that. So honestly, keeping it out of a VPC technically is probably more secure. But when you see the exams and the answers, if they do force you to choose VPCs, make sure the VPC is private and you've enabled basically network isolation, inter container traffic.
Oh, okay. Sorry if you said that. I didn't catch that.
So Rachel, what usually ends up happening is you just specify the entire data set and that you're doing cross-validation in the code, and then it'll actually orchestrate that whole thing for you, right? You still need to obviously keep the test data set separate. Now, sorry, and I see what you're saying there, because if you're using cross-validation, you're going to be randomizing all that. You just specify the entire data set, and basically it will slice it up for you if you're using K-fold validation, right? So especially if you're mixing in the testing data in with that, yeah, you just specify one data set and it's just going to execute the whole thing for you. It'll do all the segmentations and separations with answering the questions. I've only ever done that in code. There's usually not any options to do that here that I've seen. Network isolation is basically encrypting inter-container traffic. Yeah. Good. All righty then.
Sorry, I didn't quite understand the answer to Rachel's question. Would you put in one channel, just a train channel, if you're doing cross-fold? I mean, yeah.
Yeah, you basically put in one channel because
Cross-validation.
you're using the entire data set and you're having it divvied up. And then what would happen is that once you specify the kind of validation that you're doing, it would just use that input channel and then just massage it for you and manipulate it for you.
Oh.
Yeah.
Thanks.
That's all built in, obviously. If you want manual control over that, you have to do some code control on your part, right? So. All righty then. Ian, just to say this, so this is a weird discussion. I actually had this discussion yesterday with a gentleman named Bobby Wilson over at Amazon who works with the ML team. And you're going to be creating training jobs in notebooks regardless. Are you going to come in here into the console and create a training job? No, the console is really just for learning, right? And this is a debate that I frequently have, is that notebooks are versioned artifacts that you can check into code, and they're a lot easy to visualize and easy to use and whatnot. But most ML pipelines, like CI/CD pipelines that have ML involved in them, notebooks are not really part of the equation. So when you're experimenting, yes, once you get to production, right, you're going to follow a different methodology. But as far as like, would you come in here and create a training job? Typically, no. You're going to do what you would, for example, would do in the lab. You're just going to code it out, and then that would start up the training job. And then like those jobs that you saw there, I wasn't in here creating them manually, right? I was all running them through code, right? So most of the time you're going to end up coding it yourself, because you're going to use the same block of code to define the training job. One, because you can check that notebook into version control. Two, the Python code is repeatable. What you do in the console is not going to be repeatable. Plus, you're going to get more options from doing it in code, like you're going to get more like parameters and more possibilities than you will through the console. The SDKs typically have more features than the console product do. So that's the other thing. So I would say code it yourself versus like going into the console and doing it. Because one, then you can also then check that into version control and share with your teammates, especially if it's a notebook, right? Yeah. In general, I know this is going to sound strange. Take the path that's going to allow you, one, to track all your work, and two, share your work. Even if you don't really necessarily have an initial intention to do it, click provisioning like the console, unfortunately is not the best way to collaborate and share that kind of thing. I actually, my dream is that someone would create a console where you click, and it would generate code, and then you could check that into version control. And then, but no one seems to want to do that. I mean, we're starting to see that a little bit with like other cloud providers, but I don't know why people aren't doing that. Because then if we want to get to a low code, no code thing, which everyone seems to tout, then why wouldn't we make it so that people who can't code could just click through something and then generate a bunch of code? I think everyone should code, but I'm just saying, right? Good. Okay, so things to think about. All right, so here's a few questions then. Obviously, two factors considered when determining what algorithm you use for ML problem, right? I think, is it a classification problem, right? Are we doing numbers prediction? Do we have supervised? Do we have labeled data, unlabeled data? That kind of thing. I think we talked about that enough, kind of during business formation. What are the two most commonly supported data formats for SageMaker for built-in algorithms? Cool. CSV, yes. IO protobuf. Good. Okay. Again, are there algorithms that support Parquet and stuff like that? Absolutely. But in Amazon's mind, at least for the exam, Parquet is reserved for another service that actually reads SQL directly off of S3. What is the name of that service? Because it will be on your exam. Good. What's the name of the service? Just as a little wild hair for a second. What's the name of the service that will actually create a meta catalog of your data on S3? You can also run ETL jobs against it. It has a funky name, right? Glue. Yeah. Okay. So why is splitting your data important? What are the things that we want to avoid by splitting data? What if all we did was train on the entire data set and we didn't have any validation or test data? Yeah, good, to avoid overfitting. Okay, what's it called, by the way, when we do those 70, 15, 15 splits or 80, 10, 10 splits? What is that called? Like, what's the official name for that? Actually, you're not wrong. It's also sometimes referred to as holdout validation or simple holdout validation, right? All right, so what's it called when you, for example, you want to run 5 different models with 5 different iterations and you split your data into 5 chunks, and one of those chunks is the validation set? Like, what is that called? It's definitely cross validation, but when we do it a number of folds, what is that called? Yeah, K-fold. Good. There are other variants like leave out K-fold validation and stratified K-fold validation. What if I want to create like versions of sets of models that I want to test against, and I want to randomize the data? What kind of K-fold cross validation? What are the adjectives that get wrapped around K-fold validation? If I want to randomize and I also want to create sets of models and then take the average of them. So I want to remember iterated. Yeah, so iterated K-fold validation. And then what's the thing they use to denote randomization? What's the word they use? We do it with decks of cards. We shuffle them, right? Cool. By the way, with Stratified, since you mentioned it, when do we use Stratified? When is it a good idea to look at Stratified K-fold validation? Why would we do that? What's in the data that's gonna, right? That would, yeah, imbalanced data, seasonality, right? Strong subgroupings based on either time or some other variation, right? Okay. All right. What are the 4 main scenarios for running frameworks and algos inside of SageMaker? So I'm going to give you the first one. So the first one is built in. What's the second one? So the first one's built in. The last one is third party. Second one is custom script. What's the third one? What's the one that requires you to bring your own Docker container? Custom framework. Make sure that's clear. If you just want to run a different algorithm, just change the code. That's fine, right? Create your own algorithm and just call it. You're fine. Just do it, right? But if you want to run your own custom framework, you need to bring your own container. Where are containers hosted if you want the SageMaker instances to go grab them? Where are they hosted? What's the official name of that service inside of AWS? Right, ECR, the Elastic Container Registry. Good. True or false? No matter which model you're using, you're always using a container. Is that true or false? That's true. Good. Good. Okay. 1, SageMaker natively can talk either to S3 or to 2 other technologies that you can actually pull files off of. What are the other 2 technologies? Actually, there's 3. So S3 is one that you can talk to. What other 3 places could SageMaker pull data off of? Like it can pull in the training data. EFS, FSX, and I think Peter mentioned this earlier in passing, but EBS, which is actually the hard drive service, that we don't talk about that because it's just included by default, but you could copy it to the hard drive that's attached to the virtual machine. EFS and FSX for Lustre are add-ons to the EBS hard drive that's already there. So just know there is a disk drive that's already there. So EBS, right? Good. Okay. If I want to go modify the learning rate inside of my model, I need to go to this section and change it. What is that called? That section that you're going to touch. Good. Good. There's more. We'll come back to that. A training job, by the way, at a minimum requires you to set these in order to source your input sources, like where you're going to input information, where you're going to derive it. What are they called? Channels. Yeah, the channel, right? Good. So if you want to have 5 different data sources because you are, doing test validation, training, and then you've added 2 others like special exclusion sets, right? For training maybe in a different way or doing different kinds of validation or testing, you could actually set different channel names. Remember, those channel names are defined in the documentation for built-in algorithms. So you have to go look at them to find out what you can define. You can't just make those up. Otherwise the job won't know what to do, right? Okay. Oh, what method do you always have to call when you want to actually set the parameters for your job before you actually call the training job? What is that called inside of the actual Python code? It's not PCA fit, for example. It's not PCA hyperparameters. What's the first one? Estimator. Thank you, Derek. Perfect. Good. All right. And that could be abstracted away to something else, but that's a literal method that you're calling. Cool. Any questions thus far? Are we good? All right. Perfect. Let's do this just because I literally got access to my room the minute right before we were supposed to start, which is why I was late. Let's do this. Let's just take a short 10-minute break. Maybe let's make it 13. Let's just make it even. So let's come back at 10:15. We're going to talk about model evaluation, and then we're going to And that'll probably take us right up until lunch. I think we also have to do a checkpoint and a couple other things. So let's come back at 10:15 and then we'll continue with the rest of our morning, okay? All right, I'll talk to you in a bit.